We will now continue with our study of radical expressions by discussing division of radicals, dividing radicals. There is one very important factor that you must understand in dividing radicals. I want you to pay special attention. In dividing radicals, the denominator cannot be a radical expression. Now, what does that mean? What that means is you cannot have a radical number on the denominator of an answer. For example, if you give me an answer like, say, 1 over square root 2, this is not acceptable because you have a radical number in the denominator. That is not allowed. Now, how do we remove the radical sign from the denominator? We're going to practice one of the basic principles in algebra, and that is you can multiply the numerator and denominator by the same number without changing the value of the number. Is that right? Now, also you should know that square root of 2 multiplied by square root of 2 equal to 2. You see, when a radical number is multiplied by itself, the radical sign will go. Square root 2 times square root 2 is 2. And so, what number will you multiply the numerator and denominator in order to remove the radical sign from here? You got the answer? Well, you can multiply the numerator by square root 2, the denominator also by square root 2. So watch how I do that. Multiply the numerator by square root 2, the denominator also by square root 2. What do we have now? On the numerator, I have a square root 2. On the denominator, I have a square root 2 multiplied by square root 2. Now, what is square root 2 multiplied by square root 2? Square root 2 multiplied by square root 2 is a 2. So, what will be the answer here? The answer will be square root 2 over 2. That means 1 over square root 2 is not an acceptable form of answer in mathematics because the denominator cannot contain a radical. So 1 over square root 2 has to be written by multiplying the numerator and the denominator by square root 2. Why? Because square root 2 multiplied by square root 2 is a 2. Now the answer is square root 2 over 2. That is the way we need to write the answer when you divide radical expressions. Alright, let's write it down. X over square root of x is not an accepted form because the denominator contains a radical. Alright, tell me, how will you now write it without the radical sign in the denominator? Well, we will multiply the numerator and the denominator by what quantity? By square root of x. So you know that square root of x multiplied by square root of x is x. A radical expression multiplied by itself will remove the radical sign. Square root x times square root x equal to x. So what do? Multiply the numerator and denominator of this expression by square root of x. And that will become x times square root x divided by square root x times square root of x. Now, does this change the value of this expression? No. If you don't like it, the square root x and square root x can be cancelled. They will not affect the value. But why did we do this? Because we want to get rid of the radical sign from the denominator. That is the incentive. And now square root x times square root x is x. You can see the radical sign has disappeared from the denominator and it is sitting on the numerator. It is all right for the radical expression to be on the numerator. So the answer, this has now become x times square root of x divided by x. And you notice one thing, the x on the denominator can now be cancelled with the x on the numerator. The answer therefore is square root of x. You see how x divided by square root of x is simplified as equal to square root of x. Now there is a name for this mathematical process that we did. What is the mathematical process we did? The mathematical process we did is remove the radical sign from the denominator by multiplying the numerator and denominator by the same quantity so that the radical from the denominator will be removed. This process of removing the radical sign from the denominator is called rationalizing the denominator. Rationalizing the denominator. So every time you simplify a radical expression, if there is a radical quantity in the denominator, you have to rationalize that denominator by using this method. Okay, let's move on and look at some examples. Simplify 1 over square root of 6. Okay, you tell me, how are we going to simplify this? Simplifying this simply means rationalize the denominator. How do we rationalize the denominator? Multiply the numerator and denominator by the quantity square root of x. So 1 over square root of x, square root of not x, square root of 6. So multiply the numerator and denominator by square root of 6. So 1 over square root of 6 equal to 1 times square root of 6 divided by square root 6 times square root 6. Have we changed the value of this quantity? No, we haven't. But what have we achieved? The denominator now becomes square root 6 times square root 6 is a 6. So this is now square root 6 over 6. The denominator, the radical sign is gone. We have achieved rationalization of the denominator. So this is the simplified form of 1 over square root 6. Another one. Simplify 4 divided by square root 5. I'm sure you can do that now on your own. 4 divided by square root 5. What do we do to rationalize the denominator? Multiply the numerator and denominator by square root 5. So 4 divided by square root 5 is the same as 4 times square root 5 divided by square root 5 times square root 5. What does the denominator now become? Square root 5 times square root 5 is 5. So this will be 4 square root 5 divided by 5. Isn't that simple? But very important. Another one. Simplify x divided by square root 13. The same process. Rationalize the denominator by multiplying the numerator and denominator by square root 13. That's right. So x divided by square root 13 now becomes x times square root 13 divided by square root 13 times square root 13. Alright, what does the denominator now become? Square root 13 times square root 13 is 13. So the answer is square root 13x or x square root 13. It doesn't matter how you write it. But the denominator is square root 13 divided by square root 13 times square root 13 is 13. Okay, another one. Simplify 14x divided by square root of x. Okay, I'm sure you can do this on your own. Alright, stop the video now and try it on your own in a piece of paper. And then come back and watch. 14x divided by square root of x. We rationalize the denominator by multiplying the numerator and denominator by square root x. So 14x divided by square root x is now written as 14x times square root of x divided by square root x times square root x. The denominator now becomes square root x times square root x is x. So that is 14x square root x divided by x. What can you do here now? X on the denominator will cancel with the x on the numerator, leaving us with the answer 14 square root of x on the numerator. And what is my denominator? It's a 1. So the answer is simply 14 square root x. Alright, let's try another one. Square root of 16 divided by 7. Simplify. Now, do you remember any rule that we have done in order to simplify quantities like this? Square root of 16 divided by 7. The method that we have to use here is the quotient rule I gave you. I don't know if you remember that rule. Square root of a over b is square root a over square root b. That is the quotient rule. So we use the quotient rule here. And how does this become using the quotient rule? Square root 16 over 7 will be square root 16 on the numerator and square root 7 on the denominator. There you are. So that will be square root 16 over square root 7. Well, square root 16 is 4. So that will be 4 divided by square root 7. But is this an acceptable form of the answer? No, it is not. What do? Rationalize the denominator. And how do we do that? Multiply numerator and denominator by square root of 7. So 4 over square root of 7 now become 4 times square root 7 divided by square root 7 times square root 7. And now the denominator is square root 7 times square root 7 is 7. So that will be 4 square root 7 divided by 7 is the answer. Okay, let's move on to another one. Simplify. Square root of 4 over 3 times square root of 3 over 4. Can you think of a rule that we have done which will make it easy for you? Well, this time it is the product rule. Square root of a times square root of b is square root of a times b. You see, those rules are very important. You must be able to use it in any possible ways. Well, square root of a times square root of b is square root of ab. And in the reverse process, we have been using this quite a lot. Square root of a times b is square root of a times square root of b. Remember, this is what we have been using in simplifying radical expressions in the last two lessons. And this and this are the same thing. So, what will this become using this rule? Square root of a times square root of b equal to square root of ab. Square root of 4 over 3 times square root of 3 over 4 is square root of what? 4 over 3 times 3 over 4. Okay, let's write that. So, using the product rule, this now becomes square root of 4 over 3 times 3 over 4. Well, you know, 3 and the 3 cancels, the 4 and the 4 cancels. So what is this? This is a 1. That's equal to square root of 1, which of course is a 1. Okay, so you must be familiar with all these simple rules and know when to use what rule to simplify these kind of simple expressions. Another one. Simplify 2 square root 3 divided by cube root of, I'm sorry, I didn't read it correctly. 2 square root 3 divided by square root of y cube. We have a square root y cube on the denominator. You cannot have a square root in the denominator. What do? Multiply the numerator and denominator by square root y cube. Alright, let's do that. So 2 square root 3 over square root y cube is 2 square root 3 times square root y cube divided by square root y cube times square root y cube. What does the denominator now become? When a radical expression is multiplied by itself, the radical sign will go square root y cube multiplied by square root y cube is y cube. So that will be 2 square root 3 times square root of y cube. Look at the way I wrote square root of y cube. I wrote square root of y squared times y. Can you tell me why I wrote that way? Because square root y cube can be simplified. Y cube can be written as the product of a perfect square. Y squared is a perfect square. So y cube is written as y squared times y. And the denominator is square root y cube times square root y cube. That is y cube. What is our next step? On the numerator, the square root y squared times y. You can split that into 2 as square root y squared. There you are. I split this term into 2 pieces. That is square root y squared times square root y. Okay? What is the value of square root y squared? Square root y squared is y. So this now becomes 2 square root 3. 2 square root 3. Let me write that step one more time. Rather than, now look at the way I'm going to write that step. That will be 2 square root 3 times y times square root y divided by y cube. Alright? This is now 2 square root 3 times y times square root y divided by y cube. And now, if you watch this, square root 3 times square root y. You see? They two can be put together in one radical. Is that right? Square root a times square root b is square root of ab. So I picked the square root 3 and square root y and wrote it as square root 3y here. So look at the numerator now. That is 2 times square root 3y times this y. That is how the numerator became this. 2 square root 3y times y over y cubed. I hope that is clear. And now let me clear that out. Can you simplify this now? There is a y cube on the denominator, a y on the numerator. Use the quotient rule to simplify that. Right? The denominator power is greater. That means this y will go from the numerator and the denominator becomes y to the power of 3 minus 1, which is y squared. So the y on the numerator will go, y cubed now becomes y squared. You see that? So the answer is 2 square root 3y divided by y squared. Now, some of the very important skills that we used here, you must be thorough with. Okay, let's try another one. Square root of 5p q to the power of 4 over 2r. Square root of the whole quantity. What should be done here to simplify it? Well, here we will split that as a numerator term and a denominator term. Separate the numerator and denominator. In other words, square root of a over b is square root of a divided by square root of b. So what will this become? Square root of 5p q to the power of 4 over 2r is now written as square root 5p q to the power of 4 divided by square root of 2r. Separate the numerator and denominator into 2 radicals. Now, what is the next thing you can do? I see 2 things here. First of all, I see on the numerator there is a q to the power of 4 which can be simplified, which can be separated out into a different radical because it is a perfect square. Denominator has a radical. That means we need to rationalize the denominator. Now, how do we rationalize this denominator? Well, multiply numerator and denominator by square root 2r. Alright, multiply the numerator and denominator by square root 2r. This now becomes square root 5p q to the 4 times square root 2r over square root 2r times square root 2r. Well, on the numerator we can use the product rule, can't we? Square root of a quantity times the square root of another quantity is square root of this quantity times that quantity. So, I'm going to do that. I have done 2 things in here. First of all, I separated, I wrote q to the 4 in a different radical. Why did I do that? Because it is a perfect square. And then all the other terms, square root 2r and square root 5p, I put together in one radical. Alright, one more time. This numerator can be written as, let me show you that in another step. That numerator I'm going to write as square root of 5p q to the 4 times 2r, and the denominator will be 2r. Is that right? Square root of this quantity times this quantity. And now, what I did in this step is separate the perfect square quantity q to the power of 4 in a separate radical and leave the others 5p times 2r. So this step means square root of 5p times 2r times square root of q to the 4 all over 2r. And now simplify that. In our next step, we will say square root of q to the power 4. Tell me, what is that equal to? Square root of q to the power 4. How do we take the square root of a power? By dividing the power by 2. So square root of q to the power 4 is q to the power 4 divided by 2. And that therefore is q squared. Square root q to the power 4 is q squared. Well, I think we have done practically everything that is possible to simplify, and let's rewrite this answer as q squared square root 10pr all over 2r. The same thing, just reorganized it. Okay? Alright, let's see if we have another one to simplify. Simplify 1 over cube root of 4. Alright, this time the denominator is not a square root, it is a cube root. Now, how do we remove a cube root from the denominator? Well, let me see if you remember this. Well, you know that square root of x multiplied by square root of x is x. Alright, suppose I have cube root of x. Now, how many times do we need to multiply cube root of x to get x? It is cube root of x times cube root of x times cube root of x. You need to multiply cube root of x by itself 3 times to remove the radical. You see? Square root of x times square root of x is x. Cube root of x times cube root of x times cube root of x is x. So if you have a cube root, you need to multiply this by itself 3 times to remove the radical. So, if you want to remove a cube root, multiplying it once will not remove it. You got to multiply cube root of 4 2 times on the denominator and 2 times on the numerator. Then only the cube root will be removed. Alright, I hope you understand this. To eliminate a cube root from the denominator, we use this property. Cube root of x times cube root of x times cube root of x is cube root of x raised to the power of 3, which is x. That means the cube root has to be multiplied by itself 3 times. Now, cube root 4 times cube root 4 times cube root 4 is 4. So what do we do here to remove the radical from the denominator? Multiply the numerator and denominator by cube root 4 times cube root 4. Why? We have 1 cube root 4 on the denominator. To remove that radical, we need 2 more. So multiply the denominator by cube root 4 times cube root 4. Also the numerator by the same number. So look at the change we have now. It is 1 over cube root 4 equal to cube root 4 times cube root 4. We multiply the numerator. And this cube root 4 on the denominator is multiplied by cube root 4 times cube root 4. We haven't changed anything. If you want, you can cancel them. But we don't want to cancel them. We did this for a purpose. What is the purpose? The purpose is to make the denominator a whole number. Remove the radical from the denominator. What is cube root 4? times cube root 4 times cube root 4. That is 4. Alright, can you simplify the numerator? What is cube root 4 times cube root 4? Use the product rule. Cube root of A times cube root of B is cube root of AB. Cube root 4 times cube root 4 is cube root of 4 times 4. So the numerator can be written as cube root of 8. Is that right? No, cube root of 16. 4 times 4 is 16. And the denominator is, what will be the denominator? Cube root 4 times cube root 4 times cube root 4 is 4. So that's what is the next step. We have cube root of 4 times 4 divided by 4. And that is cube root of 16 divided by 4. Alright, let me see how many of you can simplify cube root of 16. Can this be simplified? Yes. If a number can be written as the product of a perfect cube, can 16 be written as a product of a perfect cube? Well, again, recall the various perfect cubes we talked about. 8 is the first perfect cube. The next one is 27. The next one is 64. You see? There is an 8 in 16. So, we can simplify cube root of 16. What do? Write 16 as 8 times 2. So that will be cube root of 8 times 2. You understand why we did that? Because 8 is a perfect cube. Okay, in that case, tell me what is our next step? Our next step is split the numerator into 2 pieces. In other words, cube root of AB is cube root of A times cube root of B. Now look at the number of times we have been using the product rule and the quotient rule to simplify radical expressions. So write this now as cube root 8 times cube root 2 all over 4. Okay, what is cube root of 8? Cube root of 8 is, alright, 2. That's right. So that will be 2 cube root 2 divided by 4. There is one more thing remaining to do. That is, the 2 on the numerator goes 2 times there. So 2 goes 2 times here. That means the numerator is cube root 2, the denominator is 2. The answer is cube root 2 over 2. Now look at the various steps that we have actually gone through to simplify this quantity. 1 over cube root 4 is cube root 2 over 2. I want you to go through these steps one more time and study these various steps. And make sure you understand it. Okay, let's try one more. Simplify 2 divided by cube root x squared. Again, we have a cube root quantity. What do we do to remove the radical sign from the denominator? Multiply the denominator and numerator by this cube root quantity how many times? Twice. Alright, multiply the numerator and denominator by cube root x squared times cube root x squared. Okay, so that is 2 times cube root x squared times cube root x squared over cube root x squared times cube root x squared times cube root x squared. We multiplied it on the numerator, multiplied it on the denominator. Okay, what is our numerator? Is it possible to simplify the numerator? Yes. The numerator, cube root x squared times cube root x squared, is cube root of x squared times x squared. Well, I want you to use your little thinking in here. That's why I'm not writing it down. I want you to think. Cube root x squared times cube root x squared is cube root of x squared times x squared. What is x squared times x squared? X to the 4. And what is the denominator? Cube root x squared times cube root x squared times cube root x squared is x squared. So this is now 2 times cube root of x squared times x squared divided by x squared. X squared times x squared is x to the 4. So that will be 2 times cube root of x to the power 4 over x squared. Tell me, can this be simplified further? Cube root of x to the power 4. You see, any power greater than 3, if it is inside a cube root, can be simplified. Cube root x to the 4 can be simplified. Why? Because x to the power of 4 can be written as x to the power of 3 multiplied by x. So we will now write this as x to the power of 3 times x. So the numerator now is 2 times cube root of x to the power of 3 times x, and the denominator will remain as x squared. Why did we do like this? Anybody tell me? Why did we do like this? Why did we write x to the 4 as x cubed times x? Because x cubed is a perfect cube, and that can be separated out. So in our next term, we will separate this radical term into 2 separate radicals using the product rule. Cube root of AB is cube root A times cube root B. So that will be 2 times cube root of x cubed times cube root of x all over x squared. Alright, tell me, what is cube root of x cubed? Cube root of x cubed is x. So this numerator now becomes 2x times cube root of x, and x squared on the denominator I wrote x times x. Well, to make it easy for you to simplify, the x on the numerator goes with 1x on the denominator, and what is our final answer? Our final answer is 2 cube root x on the numerator and x on the denominator. Well, that has been a beautiful quantity to simplify. I hope you followed the steps that we did. Well, we have actually done enough number of problems in simplifying or dividing radical expressions. Now, you need to practice that process of rationalization of the denominator. All right? I will continue this process in the next lesson. I will review the multiplication. We haven't actually done multiplication. We will do multiplication of rational expressions in the next lesson. Also review some more of division. All right? I will see you for the next lesson. That is the last lesson in this unit later on.